We are supposed to reduce this differential equation to this differential equation by the means of this as the form of substitution. And if you were to look at the new differential equation, it has only w and x, which means that from the original differential equation, we are supposed to replace y, okay? Because y has to be removed so that we can be left with just w and x. So I'm going to start with this. So w is equal to x squared plus y squared. Let's differentiate this because that will give me a version for dy dx. So on the left hand side, implicit differentiation will give us dw dx, and differentiating x squared with respect to x, it is going to give us a 2x. Implicit differentiation for this, differentiating with respect to x, it is going to be 2y dy dx. Now from here, of course, we can try to make dy dx a subject. Or else, if you were to just observe what we have on the right hand side here, if I were to divide this by 2, we will actually get exactly the same expression as on the left hand side of the original differential equation. So let's just do that. I think the substitution will be even smoother. So I'm going to take this, dividing it by 2. This will give us a y dy dx. And this is going to be just left with an x. Is going to be equal to half of dw dx. And now we have this expression to be equal to this, which means that from the original differential equation, let me write that down first. The original one is y dy dx plus x, which is actually just this. This is equal to the square root of x squared plus y squared, and x squared plus y squared is w. Now we are ready for our substitution. So this, I'm going to replace it by half dw dx. So this is going to be equal to square root of w, which means that dw dx, this is going to be equal to 2 times of the square root of w. And this here is the fw. The question actually asked for it, so we should write that down in our solution. So fw is equal to 2 square root of w. We're supposed to, in this part of the question, solve this differential equation, but from the previous part, we have already managed to reduce this into a form that is like this. And this form here is a variable separable. So if we were to stick to the process that we have in our topic outline on the Achevas TV, what we are going to do is to divide this square root of w over to the other side, and that will give us a 1 over square root of w. This is dw dx. Still, this is going to be equal to 2. So I'm going to be integrating this. So integrating both the left and the right hand side with respect to x. On the left hand side is going to be integration of 1 over square root of w dw. This is equal to integrating of 2, which I'm going to take it out from the integration notation. So I'll be integrating 1 with respect to x. And 1 over square root of w, we can actually re-express it as w to the power of minus half. So integrating this with respect to w, it is going to be w to the power of half divided by half. It is going to be equal to, here will be 2x plus an arbitrary constant. I'm going to go for a. Multiplying half across to the other side of the equation, it is going to be w to the power of half, which is going to be square root of w. It is going to be equal to x plus half a. And for half a, I think I'm going to just re-express it as another arbitrary constant. So I'm going to just say that this is x plus b, where b is representing half a. And w is, according to the question, x squared plus y squared. So I'm going to replace this w. So this is going to be square root of x squared plus y squared. And this will be equal to x plus b. We're going to try to solve for b to get a particular solution to this differential equation. And to solve for b, I'm going to make use of this set of information that is given to me here. So according to the question, when x is equal to 3, y is equal to 4. So substituting these two values in, we will have a square root of 3 squared plus 4 squared. This is equal to x, which is 3 plus b. And square root of 3 squared plus 4 squared is square root of 25. It is equal to 5. So 5 minus 3, this tells me that b over here is equal to 2. So now we have our particular solution, and that is square root of x squared plus y squared is equal to x plus b, which is 2. We're given a second order simple differential equation. So in order for us to find the solution, let's first try to find dy dx, and that can be simply done by integrating the right hand side with respect to x. So integrating 1 over x with respect to x, it is just ln modulus of x plus an arbitrary constant. I'm going to go for an a. And as for ln modulus of x, x is bigger than 0, so the modulus here doesn't really matter. I'm going to rewrite this as ln x plus a. And in order for us to get y, we have a first order simple differential equation. So getting y is just again integrating the right hand side over here. So it will be integration of ln x plus the constant a dx. As for integration of ln x, we will not be able to do it directly. So we are going to apply integration by parts by treating this as if it is a 1 times ln x. So 1 here is a, ln x here is L, and if you were to apply LIATE, we are going to be letting u be equal to L, which is ln x, and dv dx, it is going to be the a, which is 1. So differentiating this with respect to x, this is going to get us a 1 over x, and integrating this with respect to x, it is going to get us v to be equal to x. So we are going to apply integration by parts to re-express the integration of ln x, and that will be uv, that is x ln x, minus integration of v du dx, which is actually just 1. Okay, I'm going to just write it down still. So it's going to be x multiplied by 1 over x dx. And let's not forget about the constant here, a. So integrating the constant, it is going to be plus ax. You can consider writing down the arbitrary constant here, but since there's still an integration notation here, we're going to leave the arbitrary constant to the next step. So this is going to be equal to x ln x minus integration of 1 is x plus ax here, and the arbitrary constant, I'm going to go for a b. And since it is x and x here, we're going to combine this together. So this is equal to x ln x plus a minus 1 times x plus b. And a minus 1, I'm going to consolidate it to form another arbitrary constant. So I'm going to call this c. So cx plus b, where c here represents a minus 1.